Good morning, everyone, and thank you for joining us for the 7th webinar of our Associate Member Webinar Series, Reducing Embodied Carbon Through CO2 Mineralization, presented for us by CarbonCure Technologies. My name is Tracy De Silva, and I am the Office Manager with Concrete Ontario, and I will be your facilitator today. I also have joining me Oliver Zhao, our Technical Services Engineer, and he will be running our question and answer period later in the presentation. It has been our pleasure to host this webinar series and to give you all a chance to learn more about some of the products and services that our associate members provide and the opportunities they present for the concrete industry. And I'll just quickly go over some housekeeping points. The presentation will be approximately 40 minutes today with a question and answer period at the end, followed by a Kahoot pop quiz, so you'll want to stay tuned for that. All participants will be muted during the presentation, and if you do have questions, we invite you to use the GoToWebinar questions pane to type in your question. This webinar is being recorded and will be posted on the Concrete Ontario website, along with a PDF copy of the presentation, and you should see the link below on your screen. And now I would like to introduce today's presenter, Kevin Davis, West Region Sales Director at CarbonCure Technologies. Based in Vancouver, BC, Kevin Davis has several years' experience in managing sales and marketing initiatives across a number of sectors in the concrete construction space. Having managed global sales and marketing teams, Kevin has successfully coordinated major construction markets in places as diverse as Singapore, Beijing, Delhi, Dubai, and London, while maintaining a stable North American base. Kevin is currently active in a number of sustainability and carbon reduction initiatives through organizations such as the Carbon Leadership Forum, the Embodied Carbon Network, and the Zero Carbon Emission Programs through the CAGBC and USGBC, by also being active in direct concrete industry groups such as Concrete Ontario, Concrete BC, ACI, and the NRMCA. He is able to connect focused efforts between industry and the market. Thank you so much for joining us today, Kevin. And at this time, I will turn the controls over to you.
Okay, thank you very much, Tracy. As we get into this morning, also everyone, there's a couple of times where we're going to put up some polling questions. So part of us being able to present to you as attendees is for us to understand who you are and how we can best respond and manage with you. So as Tracy mentioned, we're going to talk about reducing embodied carbon through CO2 mineralization. I'm just going to make sure that this gives me control here. Okay, whoops, there we go. Got a little too fast. There's a little bit of lag here. Now that I've got control of the screen, the reason that we're talking about this, and this might be a good time to do one of the polling questions, Tracy, is the world's building stock is expected to double by the year 2060. And so whether we use a frame of reference such as New York City or Toronto, which are obviously big metropolitan centers, the reality is we're building a substantial amount of concrete. We all understand that cement is the main constituent of concrete, and concrete itself contributes very substantially to global CO2 emissions. We all understand that. Just a matter of ensuring that this is just the reality of our world today. So how do we make that more effective? So I can see the tool that popped up there. Let's do it. So if I could get you guys to click one of those buttons and press submit, we can keep moving on from there. Now it looks like, Tracy, the poll has popped up for me as well, and I can't get back to the presentation. Can you complete that?
Certainly, I'll just close the poll now and we'll share the results.
Okay, there we go. Cool, there we go. So we've got a good mixture. So we've got about a quarter of the group are concrete producers, good representatives from the engineering and architecture firm, and then the always interesting other category. So good feedback from everyone. Thank you. So we all know that we're going to build an awful lot of concrete. So how do we make sure we deal with this and make sure we're as effective from an embodied carbon standpoint as possible? Okay. What's interesting right now, especially in Canada, is we've seen a number of federal announcements. Certainly, there's a lot of federal infrastructure funding that's going on, trying to make sure we're looking at things like life cycle analysis that are driving the decisions that we're using in concrete construction. This was something that just popped up last week, actually, from the Toronto City Council. So they're approving a strategy to reduce building emissions to net zero. Pretty ambitious goal for sure. We've seen similar elements to this in Vancouver, where I'm based, where the city of Vancouver is trying to drive carbon emissions down to about to reduce them by 40% by 2030, and the concrete industry as a whole out here is working aggressively to do that. A lot of the steps that the producers are taking already will get there, but I think it's just interesting that this is very visible at a Toronto City level as well. This might be a good place to do the second poll if you could, Tracy. There we go. So just a quick question, kind of a yes or no answer is, are you seeing that external pressure, or is it something that's coming internal from your organization as well? And we can probably close that. That's a nice quick one to go through there. Okay, good. So I'm back in control there. Well, I'm not sure whether that's a good thing that we're feeling pressure or not, but the good thing is that it is visible and it's driving the decisions we're doing when we're designing and specifying concrete to be used in construction projects in Canada. Okay. So some of the people that are feeling pressure on obviously being able to incorporate low carbon initiatives into their concrete are the structural engineers. When we look at embodied carbon, I think it's important to acknowledge the distinction between embodied carbon and operational carbon. So if we look at a large condo or a large office building in downtown Toronto, the reality is, the building code has changed substantially. Those buildings are more airtight than they ever were. If they're concrete buildings, they likely have better thermal mass than some of the things that were built. But we're becoming much more effective in terms of managing that operational carbon. So they take less energy to run than they used to because we can heat and cool them more effectively. So now the focus is really turning to that embodied carbon. So if we look at the embodied carbon element that incorporates obviously not just concrete, but could be steel and glass and everything that goes along with that, that's becoming a larger portion of the building itself. So you can see the graph as it's represented there. You see it starts to move towards that 2050 target where we're really trying to drive those numbers lower. And maybe we do the third poll that we have now, Tracy. Okay, so a little bit of self-serving initiative. So obviously CarbonCure is one of the solutions that leads towards that low carbon initiative. So just like to get a little bit of a feel as to where people are, and it'll help me put things into context as I move through the presentation and get away from the polls. Okay, let's close that now, Tracy, and we'll move along. Okay, that's good. We've got a good portion of the group at least is aware of us, so we'll move along. Okay, I'll stay off the polling button for a little while and actually spend some time presenting with you now. Okay, so why now? Big focus by governments, by institutions to really reduce emissions from the buildings and construction, as we touched on previously. 40% of greenhouse gases are actually coming from buildings primarily. We're seeing the amount of construction that continues, coming out of COVID. I think it'll be interesting to see how things move along. We're seeing a fairly good pipeline of projects that we see right now. We hope that is sustainable. that if we continue to build those buildings, we need to focus on embodied carbon and concrete particularly. If we look at those, the amount of emissions that we're going to contribute to that, even more so why we need to focus on this. And we just need to align in terms of what the mission is. And actually even CarbonCure, our stated mission is to remove 500 megatons of CO2 annually. So obviously that would require us to have a pretty good baseline of concrete producers using our technology and some of the future technologies that we're developing that look into reclaimed water and recycled aggregate. Okay. So what is CarbonCure? At a simple level, what we're doing is we're beneficially repurposing carbon dioxide to reduce the carbon footprint of concrete without impacting the performance. So our goal really is to help you achieve the design strength and width of your concrete through using our technology with the minimal greenhouse gas impact to that as possible. In the Ontario market, the CO2 that we use primarily comes from some of the petrochemical companies down towards Sarnia. Different areas of the country really are providing CO2 through CO2 gas providers such as Praxair that primarily come from the petrochemical industry. So it's a byproduct of that. It's the same CO2 that's actually used in soft drinks and a certain beverage that we occasionally drink when we're watching hockey games. So that's where the CO2 is coming from. We're not creating it. We're basically taking a waste byproduct and incorporating it into ready-mix concrete as effectively as we can. So when we inject CO2, what essentially happens is it reacts with the cement particles and actually recalcinates a portion of that cement back to calcium carbonate. And so when you're manufacturing cement, as many of you will know, you're basically heating up that limestone into clinker at about 2,600 degrees. And when you make that, actually, there's a chemical reaction that creates CO2 at the same time, plus the energy required that drives that. So potentially, if we're able to reduce a portion of the cement from a mixed design, we're able to have a fairly positive environmental impact. And so that mineralization drives that conversion back into calcium carbonate or limestone. So when we convert that into a mineral, basically what happens is we create these nanonucleation sites. So it really attracts, so think what happens when you have a magnet and you've got little shavings of iron particles like that, it basically attracts. The same kind of thing happens here is when we eject the CO2, those nanoparticles start to create nucleation sites, and that's actually what gives us the compressive strength gain that drives the mixed design optimization that we work on. And this is just an example of a scanning electron microscope image that actually shows what that looks like. So how our technology works, really three main phases. So we look at, we go into an installation phase. So you can actually see one of the boxes that our engineers install that attaches to the CO2 tank that people like Praxair deliver. This is our valve enclosure where we take that liquid gas and basically convert that and push that into the ready mix injection process. From an integration system, we're really a retrofit technology, so we incorporate directly into the batching system that any concrete producer may use. So if you're a producer and you're using Command Alcon or using Marcotte or Impact, we integrate directly into that batching software. And essentially, once we're plugged in and integrated, we run seamlessly, no different than another admixture. And then the final phase, once all of that equipment is bolted on, we actually control the equipment to deliver a controlled amount of CO2 into the concrete as it mixes. So although that doesn't look overly precise there, think about what happens when you have a fire extinguisher and you're spraying something. CO2 kind of looks like that when it goes in. So there's an injection nozzle that's placed. If it's a central batch system, it's actually placed and dispensed where all of the raw materials will go in. On a dry batch system, we're basically dispensing the CO2 on top of that. But regardless, we work with the engineering teams at the concrete producer to optimize that mix design. Here's a schematic that gives you a good example of what our overall technology looks like when it's installed from the CO2 tank on the far left to our enclosure nozzle. We obviously, so our enclosure system, our dispensing nozzles, whether it's a central batch or a dry batch system, and then we incorporate into the concrete batching system at the producer in their batch room. What I'd like to queue up next, we've actually got, they say a picture is worth 1,000 words, so a video is a little bit better. We've actually got a nice little animation that walks through what CarbonCure looks like. It's about 2 minutes long, so should run quite well if we could start that up. You might have to start that, Tracy, for me.
CarbonCure technology is made up of two boxes: the control box, which is the brains of the operation, and the valve box. The valve box connects to a CO2 tank and delivers a metered quantity of CO2 into the concrete mix. The CO2 is stored on-site in a pressurized tank provided by industrial gas companies. The control box monitors the performance of the valve box system in real time and feeds back all usage data to the CarbonCure command center. The control box software integrates seamlessly with all existing batching software, so adding CO2 into a mix is just like adding an admixture, meaning no impact on batching or loading cycle time. Transfer hoses deliver liquid CO2 from the supply tank to the CarbonCure valve box, which is at the plant loading area. The valve box then meters and delivers a known amount of CO2 into the concrete mix based on the cement content of the mix. The CO2 automatically injects into the mix once roughly half the cement and water contents have been discharged. While liquid CO2 is stored in the tank on site, the CO2 that comes into contact with the concrete is actually in a solid and gaseous state, similar to dry ice or snow. It changes state once it leaves the CarbonCure valve box due to a significant drop in pressure. Upon contact with the mix, the CO2 undergoes a chemical reaction and converts into a mineral, calcium carbonate, which makes the concrete stronger. Plus, what was once CO2 is now eliminated, never to be re-released into the atmosphere, even if the concrete structure is demolished.
Go, thank you, Tracy. If we can just flip back to the presentation now. Here we go, thank you. I think that video is quite interesting. I think it does a good job of explaining what it is that we're doing. Not that you can get a camera inside one of those mixing drums, but we've tried to make it as realistic as possible. So when the CO2 is injected to the concrete, as we discussed, is what's driving the decision to allow us to look at the environmental impact is looking at compressive strength gain. So this is just an example of a chart that we would see from some typical testing that we would do with the producer. The bar on left is the control. The bars on the right, the orange bar, is the the sample that has CarbonCure incorporated into that. So what we'll typically see over those testing periods when we break the cylinders at 28 days as an example, we may see a strength gain of up to 10%. So if you're designing a 25 MPa concrete, you don't need your 25 MPa concrete to be 10% stronger. What you want to be able to do is to have the optimal environmental impact. So what we'll do then is we'll take out a portion of that cement. We'll obviously continue to optimize the dosage of the CO2 and then try and deliver that optimal 25 MPa concrete with the most reduced environmental impact as we can. So this is an example of a similar type chart where the bar on the left is the control, the bar in the center, the black bar, would be what would happen if we reduce the cement. Obviously, it would be less strong. And then the bar on the right, the orange bar, is when we have CarbonCure incorporated. So we bumped the strength back up to the compressive strength that was targeted in the design phase. So when we look to optimize this, we hear sometimes as well, we make the concrete stronger. Is that what's driving the decision? Certainly it does, but what we're trying to do is just optimize the performance with the producer, with the optimal amount of cement and the other raw materials that they're using, and an optimal dosage of CO2. So typically what we'll see on a cubic meter of concrete is roughly we'll reduce the environmental impact through cement reduction of 10 to 15 kilos of CO2 reduced. And so this is important because we start looking at the global warming potential of a project, and it starts to add up pretty substantially. If you have a larger project that might have 20, 30, 40,000 cubic meters of concrete, you can imagine the reduction starts getting into the hundreds of thousands of tons of CO2. And so that's what we're trying to do, is sequester that CO2 permanently in the structure through using our technology. So that's an example of what we see. What people always want to know, though, is, okay, well, what happens to the concrete? If you're injecting CO2 into it, do we have any kind of impact on the fresh properties or the hardened properties? And typically we don't. I was on site yesterday actually supervising some testing, and we don't see things in terms of looking at workability or slump. We typically are not impacting the air content, pumpability, all those types of things that your contractors or your placers or finishers are really going to be looking at. Is they don't want concrete that sets up any longer. They just want what they've always had. And that's really what we try and do, is to deliver concrete that's just like they had, with a better environmental footprint. From the hardened properties, and we've got some good white papers that support this from a durability standpoint, in terms of looking at testing in terms of strength, longer term performance of the concrete in Canada. Things like freeze thaw are particularly important to us, pH levels and what have you. So typically we're not going to impact things differently than you see in your traditional mixed designs that you're already using. So where is CarbonCure? We've got locations, actually, we're pushing almost about 400 plants, primarily in North America, as you can imagine. We're based out of Halifax or Dartmouth, Nova Scotia. We have a good footprint across North America, as you can see here. We actually just did our first installation in New Zealand, of all places. So maybe we can get a rugby match going with those guys. So, but it's a really big focus for ours, and we're really trying to rapidly expand. You may have seen earlier this year, we successfully won the Carbon X Prize. And what one of the things that will come along with that is it's enabling us to invest in the people and technology that we need to scale up the business even more rapidly. And we're starting to grow exponentially. Some of you on the line are part of the reason for that, which is great, and we appreciate your support. But really a global initiative within CarbonCure. We're now actually pushing about 10 million cubic meters that we've poured with CarbonCure. I can remember last December, I think we did our 1 millionth truckload. So things like that are pretty big milestones for a company like us. These are some examples of some projects that we've done. So just to give you some idea of the scope and where we're starting to work, this project was done a little more than a year ago with our friends in Calgary on a de-icing apron, a little more than 25,000 cubic meters, poured pretty rapidly through a portable plant. So going through a slip form paver, ultimately saved about 160 tons of CO2. And this was something that was driven in Calgary through WestJet and the Calgary airport. And we're actually just getting ready to do another phase with this. So as much as we do most of our business through batching plants that are located at a physical ready mix facility, we do have on larger projects the ability to integrate into portable plants. And as many of you will know, these plants, although they're portable, they fit on 4 or 5 trucks. They're not really super nimble. But that's a good example of a project. These are projects, and you'll see a lot of this type of construction in Ontario also. This project happens to be based in Tennessee, just as an example. But you've got a lot of tilt-up walls, you've got a lot of slab on grade, you've got a lot of parking. All of these are areas where potentially you can integrate CarbonCure into the mixed design. And so, this is something where we really focus on. One of our investment backers is Amazon, and as many of you will have seen, there's a lot of Amazon distribution centers. These are the types of projects that in many cases are big enough for a producer in a new market to adopt our technology and figure out where we go from there. We're actually doing a project in Oregon right now with Facebook, and it's really driven the producer to come on board and expand and support that, and then integrate CarbonCure into the balance of their business. So this project here, you can see the equivalent carbon savings of 82 acres of trees absorbing CO2 for a year. So pretty substantial projects like this, and these are things that we look at and work with producers to be able to support to enhance their business, and then work with the engineering and design community to make sure we're delivering the most efficient performance we can. Just some other examples of projects that you can see here. We've done some high-tech stuff, lots of things in the Bay Area and California with things like LinkedIn. We've done things like hockey arenas in Halifax, as you can imagine. Actually, the project, the RBC Center, was quite interesting because in addition to just the regular construction phase, it was the base for the ice pad as well. And the finishability of the concrete was extremely important. So as you can imagine, with a lot of these multi-purpose arenas, it's everything from an ice rink to a trade show floor. So all those things have to have be able to be incorporated. The de-icing apron, as we've touched on earlier, we've done some work with the Departments of Transportation and exotic places like Hawaii. So not that that's particularly relevant to you, but that's driven to work that we're doing with the Chicago DOT in Illinois and Iowa, where the performance of the concrete would be more similar to what you see in Ontario. Some customer success stories, and these are really important to our business, is our customer ultimately, and who CarbonCure really transacts with, is the concrete producer. And these are examples of a number of producers that have multiple locations that have really integrated CarbonCure into their business model. So they're really trying to install CarbonCure into all of their facilities and be able to support all of their environmental initiatives in their particular marketplaces. So we've got some good examples here. Canadian example would be, and we're just working on some PR with them, is Butler Brothers on Vancouver Island. So very substantial producer in that market that really almost every meter they produce incorporates CarbonCure. So lots of projects in the Capital District here out on the West Coast. So why aren't we used everywhere? And this is the million-dollar question. Is we call them barriers to innovation, but in a lot of cases, it's really that prescriptive mixed design versus the performance mixed design. And I think we've all seen them, certainly with the DOTs and MOTs, where there's minimum cement contents. Ultimately, what's important is we have a concrete mixed design that delivers the performance that's prescribed for the project. So let's prescribe the performance. Let's not prescribe the raw materials. All of the concrete producers on the call, many of the structural engineers, all of you guys know what works. And I think our goal is to make sure that we can work together with you to deliver something that is obviously environmentally beneficial, meets the performance that's all critical, but let's look at the appropriate cement content and other cementitious materials that you use, such as fly ash and slag. So just a little bit of a stand on the podium for a minute, but look at the performance base versus the prescription, I think, is really critical. Look at sustainability initiatives. We're seeing a lot of these come through the Canadian market. Concrete Ontario as an organization has done a good job driving this. Cement Association of Canada is supportive in these areas as well, but go to those performance-based specs. Look at cement replacements, using SCM such as fly ash and slag, use the language that we use. Let's incorporate CO2 mineralization into there. You may see a few mix designs that say CarbonCure, but typically it's through the use of CO2 mineralization. But, to that point, easiest option is talk to your producer. Just say, hey, we've got a mix design. We need 25, 30, 32 MPa, whatever the number is. Give me your best mix from an environmental standpoint. Tracy, this would be another point to do the poll. So one of the areas that we're seeing more and more in Canada is the use of environmental product declarations. There's companies such as Climate Earth as an example that are very nimble in this area. Athena is another one. But basically think about the side of the cereal box for your concrete. And so I think the poll question we're looking at here is, you know, as a producer, are you adopting EPDs and what you're providing for your mix designs? And then also at the specification level, are you starting to require EPDs for what you're doing? So you can close that off now, Tracy. Go. So this is, you know, not entirely surprising. It's interesting where we're seeing more EPDs being requested. We're seeing more producers responding that to a certain extent. There's certainly national and regional programs for this, but we're certainly seeing from the requests that we're getting from customers of making sure that you've got specific local EPDs for your particular plant. There's a cost to this, certainly, and I think that's one of the limitations initially, but I think it's going to become more of a standard practice and almost a condition for doing business. So we're seeing much more of these to being adopted. So people are asking for it. You know, be proactive if you can. You know, look at things like we use the term internally all the time. GWP is, let's have a good global warming potential number on this concrete. And what they're really trying to target is the sort of kilos of CO2 that are emitted per cubic meter of concrete. Okay, it's lagging a little bit here. One of the great tools that we see is there's I think the actual website I think is buildingsustainability.org, but it's the what we call the EC3 tool. So it's an embodied carbon tool. So this is actually a repository for any concrete producer, anyone who has a mix design can upload their mix design and their EPD into this, and it will really tabulate this. So there's tools being developed that make it easy. So if you're, for the designers on the call, if you're designing something, you can look at different building architects. You can say, I'm building a 30-story building. What does it look like if I do concrete? What does it look like if I do steel and glass? What are the environmental ramifications of the designs that I'm putting together? So there's some really good tools that have been developed out there. This was developed through some of the Microsoft projects, and some of the drivers were Skanska. We were involved at the front end, people like BAS and Master Builders. So there's really good mixed design examples out there where you could take that initial mixed design that could have been high, so 521 for sure would be pretty high, to something that's lower in the 290 ranges. And very honestly, we're seeing mixed designs with lower embodied carbon that are 220, 230, 240 would be quite common in the Pacific Northwest. So look for tools like that. If you just Google, you know, embodied carbon calculator or EC3, there's a link, and this is a no-cost tool that any of you can download and look at. So it's my plug for EC3 for the day. So where are we going? I think, you know, this is becoming part of our lexicon, if you will, is how do we decarbonize concrete as effectively as we can. We want to make sure from CarbonCure standpoint that we're working with the concrete producer to make sure they have ways to be profitable and differentiated, being able to effectively you know, do a rapid plant retrofit. This is an area where actually COVID, as we're coming out of this now, almost helped us to be more nimble. And you know, early on in our adoption, we used to fly engineers around North America like Batman to install systems. What we found is that concrete producers are pretty effective at running their own plants, and you know, it's not quite this simple, but essentially we're shipping a crate out to a customer now with a manual and walking them through this remotely and then going in afterwards to supervise if we need to. So this is where COVID has driven some innovation on our standpoint. Really being able to integrate into the system overall, and really that continuous innovation of low carbon digital technology. And the digital part for us is really being able to calculate those carbon savings. And we're actually going to market in some cases with selling those carbon offsets or carbon credits, but that's a whole other discussion. And then working to develop those partnerships across the whole value chain, really making a circular economy. So that's the conclusion of the presentation. So a lot of information that I threw at you there. certainly some I think valuable insights in terms of seeing the makeup of the group on the call today. But I think from CarbonCure's perspective, we're very pleased to see the adoption in the North American market of our technology. We truly believe that we're starting to have a more positive environmental impact the more that we can scale. And we look forward to working with you as producers and working with you in the design community to make lower carbon buildings. So with that, I'll wrap up and I'll let Oliver go into his pop quiz. So I hope you were paying attention.
All right,
Thank
you,
Kevin. Oliver, I'll turn it over to you for the question and answer period.
Yeah, thank you, Tracy. Great presentation, Kevin. A lot of information. Just to let everyone know, if you guys have any question for Kevin, please feel free to type in the question box. So I think, let me go through the questions. So Kevin, first question for you. What is the approximate time frame or range to install one of CarbonCure equipment at a particular concrete plant?
Yeah, so typically it's about a day to do the installation once we have all of the equipment there. So, you know, from our standpoint, if we can coordinate the lead time and have our equipment on site, we need to make sure that we have a CO2 tank installed and full of CO2. So once all of those components are there, it's really only a physical day to do the installation. That's when the work begins though, and so then we'll go through a phase of testing and validating the technology with the particular customer's local raw materials, and that would be a 60 to 90 day process to validate all the technology. But the equipment is the easy part, about 1 day.
Awesome. Another question that's related to the previous one. Would you be able to share about the options that the producer may have in terms of buying their own equipment or maybe a rental option, lease option from you?
Yeah, so at a basic level, our technology it's not a, from a positive perspective, it's not a CapEx. So we actually run a lease license model. And so what we do is we adapt that license model to the size and scale of the producer and what their goals are. You're also going to lease a CO2 tank from the concrete producer. So there's sort of two elements there. There's the CO2 tank, and then there's the CarbonCure technology. So the benefit of leasing from our standpoint is that because we own that equipment, if you will, we're responsible for maintaining it. It is very low maintenance, I can tell you that. We have the ability also to connect into it remotely. So we have the ability to troubleshoot really from our data center in Halifax as well. But basically it's a lease license model. Feel free to reach out to me directly if you're looking at something specifically for your plant location.
Okay, great. Next question. So the video shows CO2 being injected into a central mixer. Can CarbonCure be retrofitted to the other kind of batching system?
Yes, they can. So it's interesting. I would estimate that probably 40% of our installations are in what we would call dry batch plants. And so we use central mixer because that would be common, and certainly in the major metropolitan areas, the higher volume plants tend to be central mixes. But a lot of our business is, you know, what we would call rural, so smaller locations across North America, and those tend to be dry batch plants. But we easily integrate into that as well. One of the things that we do prior to installation is we do a site visit to understand how we optimize that. So we look at everything as detailed from what's the optimal placement for the injection nozzle. Is there a longer cycle time where we might need 2 injection nozzles? How do we integrate batch-wise? Those are all part of the question that we go through and validate before we do the installation. But it's a good question. But yeah, we can address most of the common mixer types. It's a matter of just preparing for that going in.
Great. A technical question here. would the addition of CarbonCure to the concrete mix affect the water cement ratio limits from CSA?
That's a great question. So we're actually incorporated as one of the addendums within CSA. That's one of the things that drove us into getting some of the airport work that we're going. So occasionally there needs to be adjustment there. So obviously if you're going to reduce cement, your WC is going to change somewhat. We have found in general that the design community has been kind of responsive to working within the design parameters within CSA. So there can be a slight adjustment that needs to be made there, but we'll work with the specifier, make sure we stay on side with CSA and work within that. But that's a great question.
And Kevin, a final question. I believe we have an engineer who was very attentive listening to your presentation, asking was the CO2 savings reported on the slide about the Tennessee job from CarbonCure only, or also from the SCM and overstackable benefits?
So all we reported on what we showed there were things that were related to CarbonCure. So we tracked, obviously, the CO2 that was embodied permanently converted, the cement reduction that was associated with that. Over and above that, though, and that raises a great question, is many mixed designs that you will see may incorporate fly ash and slag as an example, or you could be using Portland limestone cement. All of those are going to contribute to a lower global warming potential, and CarbonCure can be stacked on top of that. So we hear that term quite often, stackable, but all we reported on that particular slide were the ones that were related to CarbonCure. If you're curious, I can maybe dig up at what those other ones were, but that's a great question because the two of them go together.
All right, awesome. Thank you so much, Kevin. I think we have another question coming in. Is there any safety risks installing equipment at the plant with CO2?
Yeah, so a lot of people mix sort of carbon monoxide and carbon dioxide, which is where people are thinking about that. So because the CO2 tank is typically in an open space, so from a safety standpoint, the tank is mounted on a concrete pad. Most cases, there's bollards around it to protect against transportation issues. But because you're in the open air, you know, any safety risks associated with that would be minimal. We go through safety training when we install, and so there's safety from the gas provider's perspective, and then obviously safety around our equipment. But we take the necessary steps within, I guess I'm just trying to think, in BC it's WorkSafe, in the US it's OSHA, whatever the appropriate requirement is in Ontario. So we make sure we respect all of that. But because you're in an open space, and the tank is pressurized, very secure, anything typically would be vented, you know, up and above and really wouldn't impact directly. But great question.
All right, thank you again, Kevin, for answering all the questions. I guess at this point, to respect everyone's time, I'm just going to hand back to Tracy for the pop quiz.
Thank you, Oliver, and thank you very much again, Kevin. That was very informative. And I hope everyone was paying attention because we are now going to move into our pop quiz portion. So if I could ask everyone to get out your smartphone and log into the website that you see listed on the screen, www.kahoot.it. This will allow you to log into the game without any need to download an app or anything of that nature. We'll display a pin on the screen shortly. And at that point, we would ask you to enter your email address so we can send you a prize if you finish in the top 3, and your nickname for the game. Please remember this is a family show, and we ask that you please use something that your HR department would agree with. And the faster you answer each question, the more points you earn for correct answers. And we do have some prizes up for grabs. First place will be a $150 Amazon gift card. Second place, a $100 Amazon gift card. And third place, a $50 Amazon gift card. So we'll give you the pin now. If you could please take a few moments to enter the game pin. Again, the website is www.kahoot.it. Enter the game pin, your email, and your nickname, and we'll get started shortly. We'll just give it another minute or so. Okay, thank you everyone for registering, and let's get started. And here we go. How frequently will the world building stock multiply by 2060? Okay. And it looks like our Crete takes the lead on our first question. Second question. What is the chemical formula for carbon dioxide? And everyone got that one right. Well done. And ABC has now moved into the lead. Next question. What mineral is created when CO2 is injected into concrete? Okay. And ABC retained the lead on that one. Question 4. What is the average compressive strength improvement applying CarbonCure technology? Boy, everyone was quick on the draw on that one. ABC still in the lead. Scotty Mac moving up. Question 5. What is the average amount of CO2 sequestered per cubic meter? Okay, a little bit of movement. KL on fire now. Takes the lead. Question 6. What was the equivalent saving of CO2 expressed in acres of trees for the CarbonCure project in Cedar Creek? Click on the draw again. And ABC back in the lead. Question 7. What airport has used CarbonCure for paving in de-icing aprons? And Concrete now moving up. Question 8. What is GWP an acronym for? And everyone got that right. Concrete retaining the lead with 2 questions left. Question 9. Which SCMs does CarbonCure work with? Let's see where we stand now. Concrete still in the lead. Last question. Double the points. Who should I contact for more information on CarbonCure? Please type in your answer. Okay, we'll just give another moment. Kevin Davis is the correct answer. And here we go with our standings. ABC in 3rd place. KL in 2nd, and our winner in 1st place is Concrete. Well done, everyone. Well done. Thank you so much for joining us. We'll send those gift cards out to everyone. Our top 3 winners.
Cool. That was great. Thanks, everyone.
And we ask that you join us on August the 19th for the next webinar in our session. Will be presented by London Machinery. That's August 19th from 10 to 11 a.m. Details will be posted on our website shortly. And in closing, thank you so much, everyone, for joining us today. We've had some great presentations in the series thus far, and it's wonderful to see so many of our members coming back to learn more about the topics that are being addressed. We hope to be able to gather in person sometime soon, but until we can, we hope to see you all at our next webinar in August. Stay healthy and stay safe. Thank you so much.